We're only going to briefly talk about the private class data design pattern. The reason is you already know it. If you look on the screen right now, you'll see I'm referring to the fraction class, which we've used in several different demos. To make the private class data design pattern work, you essentially have to create these descriptors, like the numerator and denominator descriptors, where you provide custom get and set accessors so you can govern how the outside world interacts with these individual members. And if we wanted to truly make it private data, then obviously we would not expose the properties at all with these two statements, but we could also control whether or not they're read-only, so we could define the set here to just simply say return, and then the set would never work. Right now we allow it to do the set. If you remember with fractions, we don't allow a denominator of 0. So we have custom logic in here to make sure, first of all, it's the right data type being passed in, and then it's the correct value. If they pass in a 0, then we force it to be a 1, because a 0 in a denominator makes absolutely no sense. If it's less than 0, then we negate the numerator and make sure that the denominator is always positive by using the absolute value. So we have all of this custom logic within our set accessor, or sometimes known as the mutator, and that is a form of the private class data design pattern. Basically, instead of just allowing free access to a class's attributes, its variables essentially, we govern it with these getters and setters to ensure that we only allow legitimate values. Now, we talk about the setters all the time. We don't want illegal data inside our class. We don't want bad data inside our class. Users are evil. They're always trying to break our code by giving us bad data in our properties. Okay, so you've heard me say this dozens and dozens of times, but we don't really talk about the getters very much. And in fact, we do need to discuss that, because let's say we're holding somebody's social security number or credit card number in the class, whereas the set, we want the entire 16 credit card digits to come in. When we call the get from the outside world, maybe we only want to show the last 4 numbers. And that is something you could easily do. Right now, all of our getters have always just simply returned the value that it's wrapping. But there's nothing that says you can't extract only key information from there, and that's what you return. So if it's a social security number, which is the private information for US citizens, it comes in the format of 3 digits, a dash, 2 digits, dash, and then 4 digits. A lot of times on forms that you get mailed to you or you fill out, it'll be like 3 X's, a dash, 2 X's, a dash, and then your last 4 digits for real. And that is something you could definitely implement in Python using a get. And that's also another benefit of Python, where you are not bound to a specific type. Whereas in other languages, like let's say it's Java or C or C Sharp, where you have to say, well, the credit card number is going to be a long. I want to store it as the actual digits. And then if you do that, then the getter and setter must accept a long as the value in, and it must return that same data type on the way out. If you wanted to provide just the 4 digits, of course you could provide those last 4 digits. But what happens if you wanted to provide it in that string format with the 3 X's, a dash, 2 X's, a dash, and then 4 X's again? Well, then you run into the problem of that's a string, and I can't return a string in a function that expects a data type of int to be the return value. So in those languages, you'd have to provide another getter that might be called formatted ID, which is going to return the string value. And then the getter for the actual ID is then just private. It just returns none. So you don't want any of the social security number or the credit card number to get back out again. So in Python, even though when we set, let's say we're accepting an int only as the input here in the setter, there's nothing that says we can't return a string here at all. So we're not tied to a specific data type then. So that's actually one of the hard things about Python, because you never know what you have until you actually interrogate it. But it's also one of the good things, because then you're not held to this very strict contract where it may make sense for the input to be one data type and the output to be another. Anyway, so private class data is essentially not wrapping your class, but creating these descriptors for access to all of your data inside of the class.